Hello everyone, my name is Eileen Torres and today I will be covering chapter 2.5, which is series of polynomial functions. So by the end of this lesson, you will understand what a zero is, how to find zeros using factoring and synthetic division, and why knowing them is important when analyzing a function or graph. Learning about zeros matters because they will tell us where a function equals zero. In other words, where the graph crosses or touches the x-axis. Zeros help us understand the shape and behavior of a polynomial graphs, and they're also useful in real-life problems, like figuring out when an object hits the ground, when profit becomes zero, or when something changes direction. Okay, now we're gonna start with the definition. The series of a polynomial function are the x values that make the function equal to 0. In other words, they are the points where the graph crosses or touches the x-axis. Zeros are important because they show us the key points that shape the graph, where it rises, falls, and changes direction. There are a few ways to find zeros of a polynomial. The first way will be factoring, if it can be factored easily. Synthetic division or long division for higher degree polynomials, but in my examples I will be only using synthetic division, and using the quadratic formula if it's a quadratic that doesn't factor nicely. So that's for the definition, and now we're gonna start by doing example number 1, which is the factoring example. So for this problem, I have f of x equals x to the second power plus x minus 6. For the first step, we're gonna set the equation equal to 0. And after we have done that, we have here x to the second power plus x minus 6 equals 0. After we did that part, we're gonna move on to the second part, where we're gonna find two numbers with product of -6, which is right here, and a sum of +1, and this is our +1. Even though the x doesn't have a number next to it, we always think of it as a 1. We always think that there's a 1 next to the x. So the two numbers that we found are -2 and +3. So -2 times +3 is -6. And if we subtract these two numbers, it will give us +1. Now, we're going to move on to the third part, which is the factoring part. We have our equation here, and this factor will be equal to x minus 2 and x +3. Now we go to the fourth part, which is the zero product property, where we're gonna set them to 0. So x -2 is equal to 0, and the result of that will be x equals 2. Now we do the same thing with x plus 3, and it will give us 0, and then it becomes x equals -3. Now we're gonna check everything quickly. We're gonna take the equation again, but instead of using x, we're gonna use 2, so we're gonna substitute it for 2, and it will be equals to 4 plus 2 minus 6, which gives us 0, and f of -3, which gives us 9 minus 3 minus 6 equals 0. So since it gives us 0 for the two equations, the answers are gonna be x equals 2 minus 3, and that will be the answers for this problem right here. So that's all for example number 1. Now we're gonna move on to example number 2, which is like the longest problem. And here in this example, we're gonna use the division. Now our problem is gonna be f of x equals 2x to the third power minus 3x to the second power minus 11x plus 6. And in this, in order to solve this, we're gonna follow these steps. So for step number 1, we're gonna use the rational root theorem to list the candidates, or like the numbers that we're gonna use. For the second part, we're gonna test the candidates and substitute them. For the third part, we're gonna use synthetic division. And for the final part, we're gonna factor the quotient and solve the remaining zeros. So for step 1, we're gonna use the rational root theorem. And the rule of this says that possible rational zeros equals, they can be either positive and negative, and they will be the factors of the constant term, which is number 6, the last term, and we're gonna divide them, and that will be the factors of the leading coefficient, which is 2. That's the leading coefficient, and yeah. Now, for the constant term, we're gonna do it first, and the leading coefficient, we're gonna do it second. So the factors of number 6 are, they can be either positive or negative 1, positive or negative 2, positive, negative 3, positive, and negative 6. Now we do the factors of 2, positive, negative 1, positive, negative 2. Now that we have them, now we're gonna make all the possible factors. So we're gonna put the factors of 6 on top and the factors of 2 on the bottom. So here we have fractions. So we have positive negative 1 over 1, positive negative 2 over 1, positive negative 3 over 1, and so on. After this, we're gonna, so basically, the top 6 factors come from the constant term. They affect the number of the possible roots. And the bottom 2 factors come from the leading coefficient, and they affect the denominator. So that's why we divide factors of 6 and factors of 2. So to test simple integers by substitution, now we're gonna take the 2 first numbers that we found, which is 1 and 2. Now we're gonna use 1, negative 1, 2, and negative 2. So first we use f of 1, and then we have 2, negative 3, negative 11, plus 6, which gives us 6 and not a 0. So this number doesn't work. Now we use negative 1, and it will give us negative 2, negative 3, positive 11, and positive 6, and that gives us 12, and it's not a 0, so therefore it doesn't work. Now we're gonna do 2, it gives us 16, negative 12, negative 22, and positive 6. That gives us negative 12, so that's not a 0. And now we're gonna do negative 2, and that's gonna give us negative 16, negative 12, positive 22, and positive 6. And this one does gives us a 0. Therefore, we found the root, and it will be x equals negative 2, because that was the number that we used. So now we need to factor x plus 2 out. Step 2. So now we're gonna use the synthetic division in order to divide the negative 2. So we're gonna use the coefficients from the problem that we were doing, which is this one. That's the initial problem that we were gonna try to solve. So we're gonna use the coefficients 2, negative 3, negative 11, and 6. So, and we're gonna divide by negative 2. So we set them here, and now we're gonna divide. So first we're gonna bring the 2 down, and then after that we're gonna multiply 2 times negative 2, which is negative 4. And then we subtract these two numbers, well, we add them, and that gives us negative 7. After that we do the same thing, negative 7 times negative 2 is positive 14. We add them, and that gives us 3. 3 times negative 2, that's negative 6, and then we add them, and that gives us 0. And that means that we're done with the division. As soon as we have 0, that means that we're done. Now the quotient polynomial will be 2x to the second power minus 7x plus 3, which are these numbers right here. Now, so far we have 2x to the third power minus 3x to the second power minus 11x plus 6, and that will be equal to x plus 2, and then 2x to the second power minus 7x plus 3. We have the number, the one that we found, and this is like the result of the division. Now we're gonna move on to step number 3, which is we're gonna do the factor. We're gonna factor the quadratic quotient. Now we have the result that we got earlier, so we're gonna factor it. Now we're gonna find numbers that multiply 2 times 3 equals 6 and add to negative 7. And those numbers are negative 1 and negative 6. So as you guys can see, 6 times 1, it will be 6. And if you add them, it will give you negative 7. Now we're gonna decompose and factor by grouping. So we put the these numbers right here, and that will give us 2x to the second power minus x minus 6x plus 3, and then it will be all equal to x to x minus 1 minus 3 parentheses to x minus 1, and then we have the same numbers here, so we use 1 to x minus 1, and then we put these two together, which are x minus 3, and that will be the result of this. Now, therefore, the full factorization will be 2x to the third power minus 3x to the second power minus 11x plus 6 equals 2x plus 2, 2x minus 1, and x minus 3. This one was the one that we got earlier, and these are the two that we just got here. Now we're gonna move on to step 4. We're gonna solve linear factors. Now we're gonna set each of them to 0, and it will give us x equals negative 2, x equals 1 over 2, and x equals 3. Now for the final step, well, not the final step. This is a step 5, which is the quick, it's the final step. We're gonna do the quick check. So it will be f of x equals 2x to the third power minus 3x to the second power minus 11x plus 6, which was the initial problem that we had, and we're gonna plug in number 3. We're gonna pick this one. So we plugged number 3, and we're gonna solve each one. So 3 to the third power will be 27, and then we multiply 2 times 27 equals 54 is from this one. Now we do this one too. It gives us 9 equals negative 3 times 9, which is negative 27. We do the same thing with negative 11 times 3 equals negative 33, and the plus 6 stays the same. Now for the final part, we're just gonna all of them up. We're gonna add them all up, and that will be equals 0. So that means that everything was correct, and that the answers are negative 2, 1 over 2, and 3. So that will be the final solution. So that's it for my lesson on series of polynomial functions. We went over what they are and how to find them using factoring and division. Basically, the zeros are just the x values that make the function equal to 0. And once you find them, you can always plug them back in to check your work. And that will be everything. Thank you so much for watching, and I hope that my lesson make it clearer. And thank you. Bye.